Hello again. Alright, rule number one, Mr. Bolt lies. We only have one more. Yay! Almost done. So again, if you could pause this and take a look at this one, try to draw a picture of this. I'm definitely not giving you as much information as you need, but I'm hoping you can pick out, oh, he's got to tell us this, or he's got to tell us this still. So it's a good scenario here where you can draw a picture and then label all the variables. So go ahead and do that. Alright, hopefully you've got a bit of a picture, and I'm hoping in your picture you're starting to see a triangle. So let's take a look at some of our important information here. We want to know how fast to tilt the camera 3 seconds after liftoff. We've got a rocket that's going up and a camera that's tracking it as it's going up. I'm going to come down here a ways and start to draw that picture. It's going to be a bad picture. So here is the camera. Alright. And then we've got a rocket here. And of course that rocket is then going to go up somewhere up here eventually. And I'm hoping you can see that triangle that is then formed from there down to here and then over. And we've got quite a few variables in this one. The first thing I see is, do we want to know what is the angle? That's what our question is. How fast is that angle changing? And a popular variable for angle is theta. So we've got theta. And that's when we want to know how is that one changing. So it, of course, has a d theta dt. And then we look, so, well, we've got a right triangle here. So we definitely have an A, we have a B, and we have a C. So A, B, and C. Alright. Now, how would we proceed here? Oh, which one of these change and which ones don't? So first take a look at A, the distance from the camera to where the rocket started. Unless you're moving your camera, that one does not change. So A is going to stay fixed always. It's not going to change. So that would be one thing you'd have to be told, I'm guessing. Let's say we're standing 500 feet away. That sounds pretty safe. Unless it's a huge rocket, 500 feet should be a safe distance. Alright. And then let's see, what about letter B? B is the height of the rocket, so that one definitely changes. So we're going to have a dB dt. Alright. Then what about C? C is the distance from the camera to where the rocket is at any given time. That one also definitely changes. Okay. So we've got 4 variables here. 3 of them are changing. We still don't have an equation to work with. So we've got to think. We're most interested in theta, because that was our question asks us. How fast does that angle change? That's what we're most interested in. So we need something that relates theta and these other variables. I'd kind of like to use A because it's not changing. That would be kind of nice. And then I'd say we'd probably want to use B. So now you got to think a little bit of trig. What relates theta, B, and A? That is going to be tangent. So we're going to take a look at the tangent of theta is going to equal, TOA is opposite over adjacent, so B over A. Alrighty. I can simplify this a little bit. Tangent of theta is equal to b does change, so that one has to stay a variable, but a does not change, so that one I can plug in right now. It's going to be b over 500. And that is what we want to take the derivative of. This one is a little bit more complicated. B, we can actually find an equation for b. So those of you in physics, help me out here. This will make sense to you. If this makes no sense to you, don't too much. But rocketry is actually a very mathematical thing. We can predict where that's going if we know how much that rocket is accelerating. So let's say our rocket has an acceleration, that A is not the same as this A. This is acceleration. Let's say our acceleration is 100 feet per second squared. Alright? That means the distance our rocket has traveled is 1/2 AT squared. If you're in physics, you hopefully recognize that equation. So we plug in the 100, and we get 100 times 1/2, which is 50 t squared. So that distance, or in this case, we're labeling that distance a b. Sorry for the many variables here, but hopefully you follow me. Is going to be 50 t squared. So b is actually 50 t squared, which it's nice to have a t in there because we're measuring this 3 seconds after launch. So seconds is going to be plugged in for t eventually. But of course, seconds is changing. The distance b is changing, so I can't plug in any numbers right now, but I can plug in that equation. So tangent theta right now. Tangent theta is equal to b is 50 t squared over 500. We can simplify that even more, right? Because the 0 will go away, the 0 will go away, and that will be tangent theta is equal to 5 over 50 is 1/10. T squared. Alright. Looks good, looks good. But we still haven't taken any derivatives yet. And we want to figure out d theta dt. So I've got to take the derivative of both sides here. So take the derivative of the left and the derivative of the right. Just like that. And then remember what the derivative is. Got to throw that in here every once in a while to keep you guys sharp. Anybody? Derivative of tangent? Ah, good. Secant squared. I remembered. I hope somebody remembered. Secant squared of theta. Of course, we technically just did the derivative of the outside. So now we have to take the derivative of the inside, which of course the variables don't match, theta and t. So we're going to have a d theta dt is equal to, the 2 multiplies times the 1/10, so that becomes 2 over 10, which is just 1 over 5. T. Hey, look, the variables do match. So we don't have to add a dt dt. Yeah, which would be kind of weird. So we want to know what d theta dt is. So we've got to solve for that. So we're going to divide both sides by secant squared. So d theta dt is going to equal, and then let's see, I'm going to have a fraction. I'm going to put the t in the top. The t is definitely in the top. In the bottom, we're going to have the 5. And if we're dividing by secant squared, that is going to be in the bottom of our fraction there. So, almost done here. This one's kind of long, I know, but we're almost there. Now that we have our derivative, we can start plugging things in.
After 3 seconds. So we are going to plug in 3 right there. But as you can see, there's another variable here. We still have a theta. We've got to figure out what theta is. So we need to do that. Let me rewrite our equation over here. Theta dt is equal to 3 over 5 times secant squared of some number. And we've got to find that theta. Alright, how do we find that theta? Well, we got to come back at a right triangle. We need to figure out what theta is. We know that A is 500. And we can figure out what B is pretty easily. 3 seconds into our launch, 3 squared is 9 times 50 is 450. Hopefully you can see where I'm going with this. If we have the opposite and the adjacent, we should be able to figure out what theta is. So the tangent of theta I don't know if my computer's going to recover from that one. I may have to leave you in suspense here. Actually, it's possible my writing utensil just died on me. Lame. Alright, this is going to be really messy. I apologize. So, the tangent of theta is going to equal the opposite over the adjacent, 450 over 500. Alright. And then how do we do that? Well, your calculator has this nifty thing called tangent inverse. Looks like tangent -1. That is what undoes tangent. And so you'll do that to both sides. So the tangent inverse of 450 over 500, that would give you a decimal. Sadly, I actually don't have access to a calculator that can do that right now, surprisingly enough. So that will give you a decimal. Once you get that decimal, you can plug it in right there. And then remember that secant, or at least just secant, is 1 over cosine. So you will have to do 1 over cosine of that decimal, square it, then multiply by 5, then do 3 divided by that number. So again, do order of operations yourself. Don't make your calculator do order of operations. Do not try to plug this whole thing into the calculator. Do
1 divided by cosine of that number squared, then multiply by 5, then do 3 divided by second answer, and that will give you d theta dt. And see if you can figure out the units for that answer. Alright, that's a complicated one, I know, but in a nutshell, the things you want to remember. First, label your variables. Then see if they change or not. Once you've labeled your variable up here,